Welcome back to the OpenVINO channel. In the previous video, video 42, we've talked about the steps to follow when operating the DL-Workbench, and I showed you an end-to-end simple example. Now, I'll demonstrate many more options, and if something is missing, please check out the full documentation of the workbench. Okay, let's open a new configuration and load, for no particular reason, SSD MobileNet and convert it to FP16. Once it's done, I can choose the target device. I can even connect to a remote target device. I need to specify the credentials, but I will run on my local machine. I'll start with CPU. Now, let's load a validation dataset. All these formats are supported. Directory structure and file format is of course important. I'm going to use a COCO format, so we need a zip file with validation and annotation directories. And I will load my dataset. I'll choose to use it, and we are ready for benchmarking. Next, I will benchmark the 3 devices I have in my system and generate few performance points for each one of them. And I execute. And I have 1 performance point for the CPU. That's good, but I want to try a wider range of parameters. So let's do group inference. We can configure multiple parameters sweep. Let's run 1 stream, batch 1, 2 streams, batch 2, 3, batch 3, and so on, or any kind of parameters you suspect will be good for this model, for this device, and execute. It's supposed to take almost 3 minutes. And I have my 4 performance points on the graph to compare and choose from. I would like to generate such a graph for each device I have in the system. So I create a new configuration, same model, but now run on the integrated GPU. 1 point is automatically generated, but I'm going to create 4 of them. Same configuration and execute, and now I have a graph for the GPU. Same thing for the VPU, the Movidius Myriad X in that case, and a group inference and execute. And I have 3 configurations, each on a different device. Next thing is to compare them. And now we can compare in pairs. So CPU versus the GPU. In this case, it is obvious that the GPU is giving me better throughput for the same latency, more than 2x. So let's remove the CPU configuration and compare the VPU. Here too, it is obvious that the GPU is giving better inference results, but do not forget you're comparing a 2-watt device to a 15-watt one. So it really depends on the specification of the products you're trying to build. One more very interesting thing to do is to calibrate the model to integer format. I explained this process in detail in video number 68, just YouTube OpenVINO 68. We go to Optimize, choose int8, and there are a lot of options to choose from. You can optimize for performance or for accuracy, and specify the maximum acceptable accuracy drop. I will choose the default method and hit optimize. Now this is a very long process where the tool tries all kind of integer and floating point combination and reevaluate the accuracy drop again and again. It takes some time. But at the end, we have an int8 model, which is hybrid model of floating point and integer, and we can compare the two. We have only 1 point for integer model, but performance jumped from the 60s to the 80s frames per second. Next to check is the accuracy. And we can see here that the accuracy dropped by only 0.4%, while the throughput increased by more than 40%. A good trade-off. If we're happy with the integer model, we can just download it and use it. Here are the files. And now we can choose one selected optimal point and pack it into a deployment package. Another thing we can do is visually test the inference. Let's select an image and press test. You can see that class number 3, which is a car, was detected. We can lower the detection threshold and get more objects. Most of them are cars, class number 3, but we also have one person detected, class number 1. Here it is. Pretty cool. Okay, we've seen a full benchmarking flow on 3 totally different devices. We saw how to calibrate to integer, pack a deployment code, and test the inference results. Thank you.